Have you ever seen a golden tiger in real life? In the hush of an old forest museum photograph, a pale striped tiger stares back at us, a reminder that nature sometimes paints in whispers rather than bold strokes. This is the story of the golden tiger, not a separate subspecies but a rare color variation of the Bengal tiger, Panthera tigris tigris. Its coat can be pale gold with faint brownish stripes and a creamy belly, a subtle palette born from a change in pigment distribution. The key lies in the chemistry of pigments, specifically pheomelanin and melanin. In golden tigers, a recessive mutation alters how pheomelanin is produced or placed in the hair shaft, creating that diluted, warm tone while leaving some striping intact. Geneticists describe this as two-allele recessive inheritance. Both parents must carry the variant for offspring to show the trait. Historical notes matter here. Naturalists in the 19th and early 20th centuries recorded pale or golden-looking tigers in museum collections and field sketches, showing the mutation existed long before modern captive breeding. Yet most reliably documented golden tigers today are found in captivity. A few private facilities and some zoos concentrated the trait through selective matings, which produced visually striking animals and drew visitor attention. That visual appeal is a double-edged sword. On one hand, golden tigers can be powerful educational tools, drawing crowds and opening doors to conversations about genetics, animal biology, and conservation. On the other hand, deliberate breeding for color can erode genetic health. When breeders select for a rare appearance, they often narrow the gene pool, increasing the risk of genetic bottlenecks and inbreeding. That can bring congenital defects, reduced fertility, and weakened immune responses. Conservationists caution that the welfare cost can outweigh the display value. It's essential to separate fascination from facts. A common misconception is that golden tigers are a wild subspecies. They are not. They are a color morph rooted in a recessive genetic change, primarily documented in Bengal tigers. Another confusion arises when people see a pale tiger photograph and assume it's a golden tiger. Lighting, age, or partial leucism can mimic the effect. Modern genetics gives us tools to clarify carrier status. DNA testing can identify animals that carry the allele even when they appear normally colored. Where possible, contemporary recommendations from conservation groups favor outcrossing and maintaining genetic diversity over selective color breeding. In situ conservation, protecting tigers in their natural habitat remains the priority for species survival. The story of the golden tiger also offers scientific insight. The phenotype demonstrates how small shifts in pigment production and placement alter appearance without erasing stripes entirely, unlike true albinism. Museum skins from the early 1900s support that this mutation predates deliberate captive programs, anchoring the trait in wild genetic history, even if modern occurrences are mostly captive. Ethically managed, golden tigers present an opportunity. Used responsibly, they can teach genetics, spark curiosity, and illuminate threats facing tigers. But used irresponsibly, they can mislead the public and inflict harm on animals through inbreeding. Today, reliably documented golden tigers number only in the low dozens globally, when historic specimens are included, extremely rare and frequently a product of captive records. That rarity should prompt reflection rather than exploitation. When we slow down and look closely at coat texture, stripe contrast, and documented lineage, we begin to understand the complex interplay of science, history, and human choices that produced these luminous animals. Conservationists and geneticists now urge that any breeding prioritize health and genetic diversity, with education framed clearly. This is a color morph, not a new tiger species. For field biologists, the golden tiger remains an elusive curiosity. For museums and archives, it is a thread linking past observations to modern genetic understanding. And for the public, it is a reminder of how fragile and intricate wildlife genetics can be. The golden tiger's tale asks a bigger question. How do we balance wonder with responsibility? If our fascination leads to better funded conservation that protects habitat and wild populations, it can become a force for good. If it drives selective breeding that harms animals, the cost is moral and biological. In the end, the pale gold coat is less important than the living wild populations that carry diverse genes, roam large forests, and keep ecosystems intact. So when you see images of golden tigers again, remember the truth woven into their fur, a recessive mutation, a long history, and a choice about how humans respond. Choose knowledge. Choose ethical stewardship. Choose the wild.